Welcome to our countdown of the top 10 ancient technologies that were way ahead of their time. Prepare to be amazed by the ingenuity of our ancestors. I'm your guide, Ridoy, and together we're about to embark on a voyage across millennia, peeling back the layers of history to uncover sparks of brilliance that defy our conventional understanding of the past. Imagine for a moment civilizations without supercomputers, without global positioning systems, yet capable of feats that still leave us in the 21st century utterly astounded. These aren't just dusty relics, they are testaments to the enduring human spirit of inquiry and innovation, a spirit that echoes through the ages. What if I told you that concepts we consider modern, sophisticated astronomical calculators, incredibly durable construction materials, even early forms of electrical devices, have roots stretching back thousands of years? It's a humbling thought, isn't it? To realize that the arc of technological progress isn't always a straight upward line, but rather a complex tapestry woven with threads of forgotten genius and rediscovered knowledge. These ancient marvels whisper stories of societies that observed the cosmos, engineered their environments, and sought to understand the very fabric of their existence with tools and insights that were, frankly, revolutionary for their epoch. So, prepare to have your perceptions challenged and your curiosity ignited. We'll journey from the sun-drenched shores of ancient Greece to the bustling cities of the Roman Empire, from the mystical lands of the Maya to the inventive heart of ancient China. Each artifact, each technique we explore is a beacon, illuminating the incredible intellectual heights achieved by those who came before us. They remind us that the universe has always been a source of wonder, and humanity has always been eager to unlock its secrets. Let's begin this extraordinary exploration. Our journey begins in the turquoise waters of the Aegean Sea near the island of Antikythera. In 1901, sponge divers stumbled upon a shipwreck, and among its treasures was a lump of corroded bronze, unassuming at first glance. Yet this artifact, now known as the Antikythera mechanism, would rewrite our understanding of ancient Greek technological prowess. It's a device so complex, so intricate, that its existence in the 2nd century BCE seems almost anachronistic, like finding a laptop in a medieval castle. What did these ancient minds create that continues to baffle and inspire us today? Imagine a shoebox-sized device filled with at least 30 precisely engineered bronze gears. These weren't just any gears, they were part of a sophisticated analog computer. Its purpose, to predict astronomical positions and eclipses decades in advance. Think about that. The Greeks, without the aid of modern telescopes or advanced mathematics as we know it, devised a mechanical model of the cosmos. It tracked the movements of the sun, the moon, and likely several planets, displaying their positions in the zodiac and even accounting for the moon's elliptical orbit using a clever pin and slot mechanism, a level of mechanical ingenuity not seen again for over 1,000 years. The mechanism also incorporated a calendar, correlating solar years with lunar months, and even indicated the timing of the ancient Olympic Games. It was, in essence, a portable universe, a testament to the Greeks' profound understanding of celestial mechanics and their ability to translate that knowledge into a working physical model. The sheer precision required to cut and assemble these gears, some with teeth barely a millimeter across, speaks volumes about their craftsmanship. It challenges the notion that such sophisticated technology was beyond the reach of ancient civilizations, forcing us to reconsider the intellectual landscape of antiquity. Its discovery was a profound moment, a jolt to our historical timelines. For decades, scholars debated its function, its origin, its sheer possibility. X-ray tomography and advanced imaging techniques have slowly unveiled its secrets, revealing a level of complexity that suggests a long tradition of mechanical engineering, much of which has been lost to time. The Antikythera mechanism isn't just an artifact. It's a window into a lost world of scientific thought, a world where the cosmos was not just observed, but mechanically modeled with breathtaking accuracy. What does this tell us? It tells us that the human drive to understand our place in the universe, to predict its rhythms and cycles, is ancient and profound. The Antikythera mechanism stands as a silent rebuke to any assumption of linear technological progress. It reminds us that brilliance can emerge in any era, and that perhaps there are other forgotten marvels still waiting beneath the waves or sands ready to reshape our understanding of the past and inspire our future explorations of the cosmos. From the intricate gears of Greece, we travel to the heart of an empire that shaped the Western world, Rome. And what underpinned Rome's architectural grandeur, its roads that spanned continents, its aqueducts that defied gravity? It was a material so revolutionary, so durable, that many of its creations still stand today, defying the ravages of 2 millennia. Roman concrete. This wasn't just a building material, it was the bedrock of an empire, a silent testament to Roman ingenuity that, in some ways, surpassed even our modern equivalents. What was their secret? The Romans, masters of practical engineering, discovered the remarkable properties of pozzolana, a volcanic ash found near Mount Vesuvius. When mixed with lime, broken rocks and water, this ash underwent a chemical reaction, forming an incredibly strong and stable mortar. Unlike modern Portland cement-based concrete, which can degrade over time, especially in harsh environments, Roman concrete often grew stronger. Structures like the Pantheon in Rome, with its magnificent unreinforced concrete dome, still the largest in the world, stand as proud examples of this material's extraordinary longevity. Consider the harbours and breakwaters built by the Romans. They often poured their concrete directly into seawater. Remarkably, the salt water didn't erode it. Instead, it triggered further chemical reactions within the pozzolanic mixture, leading to the formation of highly stable, interlocking crystals like tobermorite. This process effectively made the concrete more resilient over centuries, a stark contrast to modern steel-reinforced concrete structures that can suffer from corrosion in marine environments. The Romans, perhaps unknowingly, harnessed a chemistry that made their maritime structures almost eternal. The scale of its use was immense. From the foundations of colossal amphitheatres like the Colosseum to the intricate networks of aqueducts that supplied water to bustling cities, Roman concrete was ubiquitous. It allowed for architectural forms previously unimaginable: vast arches, soaring vaults and immense domes. This wasn't just about strength, it was about versatility and the ability to shape space in new and dynamic ways. The Romans weren't just building structures, they were sculpting their environment, creating enduring monuments to their power and skill. So, as we marvel at the ruins of ancient Rome, let's remember that beneath the weathered stone and faded frescoes lies this remarkable material. It's a legacy not just of empire, but of keen observation, empirical experimentation, and a profound understanding of material science, long before the term even existed. Roman concrete reminds us that sometimes the most enduring innovations are born from a deep connection with the natural world and its hidden potentials, a lesson that continues to resonate with engineers and architects today. Our quest for ancient technological marvels now takes us to Mesopotamia, the cradle of civilization, specifically to a region near modern-day Baghdad. Here, in 1938, an artifact was unearthed that has sparked debate and wonder ever since. The so-called Baghdad battery, this unassuming clay jar, roughly 13 centimeters high, contained a copper cylinder encasing an iron rod, all sealed with an asphalt plug. Its design bears a striking resemblance to a simple galvanic cell, a device capable of producing an electric current. Could it be that ancient Parthians, over 2,000 years ago, had harnessed electricity? The implications are, of course, staggering. If these were indeed batteries, what were they used for? Several theories have been proposed, each more intriguing than the last. One prominent idea is electroplating, using a low electrical current to deposit a thin layer of gold or silver onto other metal objects. Imagine ancient artisans, seemingly by magic, gilding ornaments or jewelry. Traces of such techniques have been sought, though definitive proof remains elusive. The very possibility, however, opens a fascinating window into the sophisticated craftsmanship of the era. Another hypothesis suggests a medicinal purpose. Could these low-voltage currents have been used for pain relief, akin to a primitive form of electrotherapy? Ancient texts do describe using electric fish for similar purposes, so the concept wouldn't have been entirely alien. Perhaps these batteries offered a more controlled, if weaker, application of this principle. Or consider a more ritualistic or religious function. Could the subtle tingle produced by such a device have been interpreted as a divine presence, used by priests to awe or inspire their congregations? Skeptics, quite reasonably, point out the lack of definitive supporting evidence. No wires, no devices clearly powered by these batteries have been found alongside them. They propose alternative explanations, such as storage vessels for sacred scrolls with the metal components serving a different, non-electrical purpose. Yet replicas of the Baghdad battery, when filled with an electrolyte like vinegar or grape juice, can indeed produce a small but measurable voltage, typically between 0.5 and 1.5 volts. It's not enough to power a light bulb, but it's certainly enough for subtle electroplating or a noticeable sensation. The Baghdad battery remains an enigma, a tantalizing glimpse of what might have been. Whether it was a true battery, a forgotten experiment, or something else entirely, it forces us to question our assumptions about the technological boundaries of the ancient world. It reminds us that innovation isn't always a linear path, and that sometimes brilliant ideas can flicker into existence only to be lost or misunderstood for millennia, waiting for curious minds to rediscover their spark. Chapter 4. Scalpels of Antiquity, the Surgical Prowess of Ancient India. We now journey to ancient India, a land of profound philosophical insights and, as we shall see, astonishing medical advancements. Long before the rise of modern surgery, practitioners in the Indus Valley were performing complex medical procedures with a level of skill and a range of tools that would not be matched in Europe for centuries. Central to this legacy is the figure of Sushruta, often hailed as the father of surgery, whose work, the Sushruta Samhita, compiled around 600 BCE, is a monumental treatise on medicine and surgery. The Sushruta Samhita is not merely a collection of remedies, it's a detailed surgical manual. It describes over 120 surgical instruments, astonishingly sophisticated for their time. These included various types of scalpels, forceps, catheters, needles and probes, meticulously crafted and often designed with animal and bird beaks in mind for optimal grip and precision. Think of the delicate work required for eye surgery or the reconstruction of a nose. Sushruta's texts provide detailed instructions for such procedures, including rhinoplasty or nose reconstruction, a technique that ancient Indian surgeons mastered with remarkable success. Consider the challenges: no antibiotics, limited understanding of germ theory as we know it, and rudimentary anesthesia likely relying on alcohol or opiates. Yet these ancient surgeons undertook procedures like cataract removal, bladder stone extraction, fracture setting, and even amputations with a surprising degree of success. The texts emphasize the importance of hygiene, the sharpness of instruments, and detailed anatomical knowledge. Sushruta, for instance, advocated for the study of anatomy through the dissection of cadavers, a practice that was often taboo in other parts of the world at the time. The techniques described were not crude. For rhinoplasty, for example, a flap of skin would be taken from the forehead, carefully shaped and sutured into place, a method remarkably similar to modern techniques. The Samhita also details methods for stitching wounds using materials like flax, hemp, or even ant heads as natural clamps. This level of innovation speaks to a deep empirical understanding of the human body and a relentless pursuit of healing, driven by observation and practice passed down through generations. The legacy of ancient Indian surgery is profound. These techniques and knowledge gradually spread, influencing medical practices in other parts of Asia and eventually reaching the Arab world, from where they later contributed to the European Renaissance of medicine. It's a powerful reminder that scientific and medical progress is a global human endeavor, with vital contributions arising from diverse cultures and eras. The precision tools and sophisticated procedures of ancient India stand as a testament to a golden age of surgical innovation. Chapter 5. The Dragon's Tremor, China's Earthquake Detector. Our exploration now takes us to the Han Dynasty in ancient China, a period of remarkable invention and scientific inquiry. In the year 132 CE, a brilliant polymath named Zhang Heng unveiled an instrument that seems almost impossibly advanced for its time: the world's first known seismoscope, an earthquake detector. In a land frequently troubled by seismic activity, knowing the direction of a distant earthquake was of paramount importance for dispatching aid and understanding the extent of potential devastation. Zhang Heng's creation was not just practical, it was an elegant piece of engineering. Imagine a large, ornate bronze vessel, perhaps resembling a wine jar about 6 feet in diameter. Around its circumference were 8 dragon heads, each holding a small bronze ball in its mouth. Below each dragon, an open-mouthed bronze toad sat, patiently waiting. The genius of the device lay in its internal mechanism, a closely guarded secret in its time, but believed to involve a central pendulum or a series of levers so delicately balanced that even a faint tremor from afar would disturb it. When an earthquake occurred, no matter how distant, the internal mechanism would shift. This shift would cause one specific dragon, the one facing the direction of the earthquake's epicenter, to open its mouth and release its bronze ball. The ball would then fall precisely into the mouth of the toad, positioned directly beneath it, creating a loud clang. This sound not only alerted observers to the event, but, more importantly, indicated the direction from which the tremor had originated. It was an early warning system of remarkable ingenuity. Historical records recount an instance when the seismoscope activated, indicating an earthquake to the west. Courtiers were initially skeptical, as no tremors had been felt in the capital. However, several days later, a messenger arrived from a distant western province, reporting a significant earthquake that had occurred at the very time Zhang Heng's device had signaled it. This event solidified the seismoscope's reputation and Zhang Heng's genius. It was a triumph of observation, mechanics, and a deep understanding of how seismic waves propagate. While the exact internal workings of Zhang Heng's original seismoscope remain a subject of scholarly debate and reconstruction efforts, its conceptual brilliance is undeniable. It represents a significant leap in humanity's ability to monitor and respond to natural disasters. In an age without instantaneous communication, this device offered a crucial advantage. Zhang Heng's seismoscope is a profound example of how ancient civilizations, through keen observation and innovative thinking, could create technologies that addressed fundamental challenges, laying groundwork for scientific instrumentation millennia later. Chapter 6. The Water Lifter, Archimedes' Ingenious Screw. We return to the Hellenistic world, to the brilliant mind of Archimedes of Syracuse, a mathematician, physicist, engineer, and inventor whose contributions resonate to this day. Among his many practical inventions, one stands out for its elegant simplicity and profound utility: the Archimedes screw. Conceived in the 3rd century BCE, this device provided an ingenious solution to a timeless problem: how to move water uphill efficiently. It's a testament to the power of applying fundamental physical principles to solve real-world challenges. The design is deceptively simple: a large screw or a helical surface tightly encased within a cylinder. One end of the cylinder is placed in water, and the screw is rotated, either by manual labor, animal power, or later by wind or water mills. As the screw turns, the lower part of the helix scoops up a volume of water. Continued rotation then lifts this trapped water up along the spiral, eventually discharging it at the top. It's a continuous process, efficient and remarkably effective for its time. The applications were immediate and widespread. In ancient Egypt, it was reputedly used for irrigation, lifting water from the Nile to fertilize arid lands, transforming barren landscapes into productive fields. Imagine the backbreaking labor it saved, the increased agricultural yields it enabled. It was also invaluable for draining water from mines, allowing miners to delve deeper in search of precious ores, and for pumping bilge water out of ships, enhancing maritime safety and efficiency. The Archimedes screw became a cornerstone of ancient hydraulic engineering. What's truly remarkable is the enduring nature of this invention. The fundamental principle is so sound that variations of the Archimedes screw are still used today, thousands of years later. You can find them in modern wastewater treatment plants for lifting sewage, in agricultural irrigation systems, and even in some industrial processes for moving granular materials. Its simplicity belies its sophisticated understanding of fluid dynamics and mechanical advantage, showcasing Archimedes' genius in translating theoretical knowledge into practical, world-changing tools. The Archimedes screw is more than just a pump. It's a symbol of how a deep understanding of natural laws can lead to elegant and enduring solutions. It didn't require exotic materials or complex manufacturing processes, just keen insight into geometry and motion. It empowered ancient societies to manage their water resources more effectively, contributing to agricultural prosperity and technological advancement. It's a beautiful example of how a single, brilliant idea can ripple through centuries, continuing to serve humanity. No list of ancient technological marvels would be complete without acknowledging the colossal achievements of the ancient Egyptians, the pyramids. These monumental structures, particularly the Great Pyramid of Giza, built for the pharaoh Khufu around 2580 to 2560 BCE, stand as enduring symbols of human ambition, organization, and engineering prowess. For millennia, they were the tallest man-made structures on Earth, and the precision with which they were built continues to astound architects and engineers today. How did a civilization thousands of years ago accomplish such a feat? The sheer scale is, well, mind-boggling. The Great Pyramid, for instance, is composed of an estimated 2.3 million stone blocks, most weighing between 2.5 to 15 tons, with some of the granite blocks in the King's Chamber weighing as much as 80 tons. These stones were quarried, often from distant locations, transported and then lifted and placed with incredible accuracy. The base of the Great Pyramid is almost a perfect square, with sides aligning closely to the cardinal directions, an achievement requiring sophisticated surveying techniques. While the exact methods of construction remain a subject of ongoing research and debate, several theories have emerged, all pointing to a remarkable understanding of mechanics and logistics. It's widely believed that massive ramps, whether straight, zigzagging, or internal spiral ramps, were used to haul the stones upwards. Levers, rollers, and immense manpower, meticulously organized and managed, were undoubtedly crucial. The precision of the stonework itself, with casing stones fitted so tightly that a knife blade cannot be inserted between them, speaks to an exceptional level of craftsmanship. Beyond the lifting of stones, consider the internal complexity, intricate passageways, chambers, and ventilation shafts, all planned and executed with remarkable foresight. The astronomical alignments of the pyramids also suggest a deep connection with the cosmos, with certain shafts and corridors pointing towards significant stars or celestial events. This implies not just engineering skill, but a sophisticated understanding of mathematics, geometry, and astronomy, all integrated into these monumental funerary complexes. The pyramids are not just tombs, they are a testament to a highly organized society capable of mobilizing and sustaining a vast workforce, developing specialized tools like copper chisels and dolerite hammers, and executing a complex multi-generational project with unwavering dedication. They challenge us to appreciate the intellectual and organizational capacities of ancient cultures, proving that with ingenuity, determination, and a profound understanding of fundamental principles, humanity can achieve the seemingly impossible, leaving legacies that inspire awe for millennia. We now delve into the fiery, often terrifying world of ancient and medieval warfare, to a weapon so potent and mysterious it struck fear into the hearts of enemies for centuries: Greek fire. Primarily associated with the Byzantine Empire, this incendiary weapon was a closely guarded state secret, a technological advantage that helped preserve the empire against numerous naval assaults, particularly from Arab fleets attempting to conquer Constantinople. Its ability to burn on water made it especially devastating in maritime battles. What exactly was Greek fire? That remains one of history's most tantalizing secrets. The precise formula was so well protected that it was eventually lost, though contemporary accounts and modern analysis offer some clues. It's believed to have been a petroleum-based mixture, possibly containing naphtha, quicklime, sulfur, and resin. When ignited, it produced an intense, sticky fire that was incredibly difficult to extinguish. Water often seemed to spread it or make it burn more fiercely. This terrifying property gave Byzantine forces a significant psychological and tactical edge. The delivery systems were also ingenious. Large siphons or flamethrowers mounted on the prows of Byzantine warships known as dromons could project the burning liquid onto enemy vessels, engulfing them in an inferno. Handheld projectors and grenades filled with the substance were also used. Imagine the chaos and terror as ships burst into flames, the fire clinging to wood and flesh, unquenched by the very sea that should have offered solace. This weapon effectively turned naval engagements into scenes from a nightmare. The strategic importance of Greek fire cannot be overstated. It played a crucial role in several key Byzantine victories, repelling sieges and safeguarding Constantinople. the vibrant capital that stood as a bulwark between East and West for over 1,000 years. The knowledge of its production was likely confined to a select few families or guilds, passed down through generations, ensuring its secrecy and preventing enemies from replicating it effectively, though many tried. Its reputation alone was a powerful deterrent. The story of Greek fire is a fascinating intersection of chemistry, engineering, and military strategy. It highlights how a single technological innovation, shrouded in secrecy, can dramatically alter the course of conflicts and the fate of empires. While its exact composition may forever elude us, its legacy as one of history's most formidable and mysterious weapons endures, a testament to the innovative and sometimes terrifying applications of ancient knowledge in the crucible of warfare. Let us return once more to the Roman Empire. Not for its concrete this time, but for another engineering feat that fundamentally shaped its civilization, the aqueducts. These magnificent structures, snaking across landscapes for miles, were the lifelines of Roman cities, delivering vast quantities of fresh water for drinking, bathing, fountains, and sanitation. They represent a monumental achievement in hydraulic engineering, civil planning, and sheer logistical prowess, transforming urban life in the ancient world. The genius of the Roman aqueduct system lay in its elegant simplicity and meticulous execution. Relying primarily on gravity, engineers surveyed vast tracts of land to find suitable water sources, springs or rivers, often many miles from the cities they were intended to supply. They then calculated precise gradients, often as slight as a few inches per mile, to ensure a steady, gentle flow of water. This required an extraordinary understanding of topography and sophisticated surveying tools like the chorobates, a type of level, and the groma, for right angles. While we often picture aqueducts as towering arched bridges, like the majestic Pont du Gard in France or the Aqueduct of Segovia in Spain, much of their length actually ran underground in covered trenches or tunnels. The iconic arched structures were typically used to span valleys or uneven terrain, maintaining the crucial gravitational flow. These arches, often built with remarkable precision using stone and of course Roman concrete, were not just functional, but also aesthetically powerful statements of Roman engineering dominance. The impact on Roman urban life was transformative. Access to abundant clean water fueled the development of public baths, known as thermae, which became central to Roman social and cultural life. It supplied elaborate public fountains, provided water for private residences of the wealthy, and flushed public latrines, contributing significantly to urban hygiene, at least by ancient standards. Cities like Rome itself were supplied by multiple aqueducts, delivering millions of gallons of water daily, supporting a population that, at its peak, reached around 1 million people. The legacy of Roman aqueducts is not just in the enduring ruins that still dot the European and Mediterranean landscape. It's in the demonstration of how large-scale infrastructure projects can fundamentally alter society and improve the quality of life. They stand as a testament to long-term planning, sophisticated engineering skills, and the Roman ability to marshal resources and labor for projects of immense scale and lasting utility. They truly were rivers of stone, carrying life and prosperity across an empire. Our final journey takes us to the lush jungles of Mesoamerica, to the sophisticated civilization of the Maya. Renowned for their stunning pyramids, intricate art, and advanced writing system, the Maya also possessed an extraordinary understanding of astronomy and mathematics, which they encoded into one of the most complex and accurate calendar systems ever developed in the ancient world, the Mayan calendar. This wasn't just one calendar, but an interwoven system of multiple counts tracking time on various scales, from the sacred to the astronomical. At the heart of their system were several key calendars. The Tzolkin, a 260-day sacred calendar, combined 20-day names with 13 numbers, forming a ritual cycle crucial for divination and ceremonies. Alongside this ran the Hab, a 365-day solar calendar composed of 18 months of 20 days each, plus a 5-day unlucky period called Wayeb. These two calendars interlocked like gears, creating a larger cycle of 52 Hab years known as the calendar round, after which a specific date combination would repeat. But the Maya didn't stop there. For tracking longer periods, they developed the long count, a system that measured time from a mythical starting date, equivalent to August 11th, 3114 BCE in our Gregorian calendar. This system allowed them to pinpoint dates with remarkable precision over vast stretches of history. Their understanding of the solar year was incredibly accurate, calculated at 365.2420 days, remarkably close to the modern value of 365.2422 days. This precision was achieved through centuries of meticulous naked-eye observation of celestial bodies from dedicated observatories. The Maya tracked the cycles of Venus with astonishing accuracy, understanding its synodic period, the time it takes to reappear in the same spot in the sky, to within a few hours over centuries. They also likely tracked other planets and understood eclipse cycles. This profound astronomical knowledge was deeply intertwined with their religion, agriculture, and political life. Their cities, like Chichen Itza with its Caracol Observatory, were often aligned with celestial events, reflecting a worldview where the cosmos and human affairs were intimately linked. Much has been sensationalized about the Mayan calendar, particularly concerning the end of a long count cycle in 2012. However, this was merely the end of one great cycle, akin to our odometer rolling over, not a prediction of apocalypse. The Mayan calendar system stands as a monumental intellectual achievement, a testament to a civilization that, without telescopes or advanced computational tools as we know them, developed a profound and intricate understanding of time and the cosmos, leaving a legacy that continues to inspire awe and scholarly inquiry. Thanks for joining us on this journey through ancient ingenuity. Don't forget to like, subscribe, and hit the bell icon for more fascinating insights into the wonders of history. As we've seen, from the celestial calculator of Antikythera to the cosmic timekeeping of the Maya, our ancestors possessed a spark of curiosity and a drive for innovation that transcends time. These weren't just primitive attempts, they were sophisticated solutions, born from keen observation, rigorous experimentation, and a deep desire to understand and shape their world. The echoes of their achievements resonate even now, reminding us that the pursuit of knowledge is a timeless human endeavor. The Roman concrete that still stands, the surgical techniques that laid foundations for modern medicine, the earthquake detectors that sought to mitigate nature's fury, all speak to a legacy of problem-solving that continues to inspire us. Perhaps the most profound takeaway is the realization that brilliance is not confined to any single era or culture. It is a universal human potential waiting to be kindled. So, as we look to the future, to the challenges and discoveries that await us, let's carry with us the spirit of these ancient innovators. Let their ingenuity fuel our own curiosity, their perseverance inspire our own efforts to understand the universe and our place within it. The story of human progress is a continuous narrative, and we are all part of its unfolding chapters. Keep exploring, keep questioning, and keep marveling at the incredible tapestry of human history and the potential it holds.